Good evening, everyone. Welcome to 10th live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta. I am a PMRF fellow and a PhD scholar from the Department of Design, IIT Guwahati. So, in this lecture, I will cover key concepts from week 10 lecture series, lecture videos. And the deadline for submitting the week 10 assignment is tomorrow, that is 5th October 2022. And if you have not finished the assignment yet, please finish them on time. Since the nature of the assignments are objectives, so this session will be conceptual, and I will try to cover some of the important concepts that will help you clarifying your doubts, in solving those assignments. So in the last week, we learned about some of these topics. We learned first about various types of product architecture. So we learned two types of product architecture. One was integral and the other was modular. So what is integral? Do you remember? So you can use the chat message or use the microphone to reply. Okay. So basically here the screwdriver is a integral architecture because although it has two physical chunks, but those are not separable and both do not have separate functionalities. Both are intended combinedly to perform only one functionality, that is to act as a screw remover or screw tightener. Okay. However, if we consider a spanner, okay, it has three components. One, similar to the screwdriver, it has a handle with a metal jaw, one part. Another part is a separable jaw and a thread. So this is the third, this is the second. Now here the three physical entities have relative motion and they interact with each other, and each of them have separate physical functional separate functions. Okay, so combinedly these two jaws used to hold a screw. However, when you rotate this particular screw, this particular jaw moves towards this particular jaw or moves away. So because there is relative motion and the functionalities are different, this is a modular architecture. So one can remove this particular thread and replace with something else if required in future. Next, we learned about different types of modular architecture. So first we learned about product architecture. It has integral and modular. Then modular architecture also have two main types. One is manufacturing based modularity. That is when we break down product functionalities based on manufacturability. For example, consider a helmet where these two physical parts are, they use different manufacturing techniques. For example, this is a transparent front panel and this is a black body. Okay, now strength wise this needs to be a bit, the purpose or the functional goal of this particular the black body is to protect the head of a person, okay, in case of any injury or accident. And the purpose of this particular windshield is also protect, but it needs to be transparent. So because there is a difference in manufacturing process required by these two materials, so we separate this particular product into two functional blocks, two modules. Okay, one is this glass transparent part, the other part is the black body. Similarly, there can be function based modular design. So if I gave an example of a sachet dispenser where in the last class I showed you that based on functionality it has four different units. Okay, one is a cutting unit, one is a dispensing unit, one is a storage unit, one is a power unit. So like that, based on functionality, when we subdivide or group the product functionalities, then we call that as a function based modular design. Then we discussed about types of function based modularities. So again, function based modularities have four main types. One is slot modularity. So what is slot modularity? So basically modularity is one where is the cursor? Okay, where we have a base platform, okay, and the modules and the base platform have certain physical slots of different shapes, okay, and this base platform has a base architecture, and when we want to extend the functionalities of this particular product, we add various modules, okay, and this kind of architecture we call this function based modularity, which is slot modularity, okay. Similar to that, we have something called bus modularity. So in bus modularity, it is very much similar to slot modularity, but difference is that the shape of the slots are same. That means within the same architecture or the platform, the slots are of similar dimension and physical shape. So whatever we are attaching, maybe those are of different functionalities or purpose, but they have a common slot. That's why it's called bus modularity. This kind of architecture is seen in computers where we have like a SATA bus architecture. Same SATA bus can go inside a hard disk drive, a CD drive, as well as some other ROM. Okay, random. Sorry, I should forgot. Okay. Then we have sectional modularity. So in sectional modularity, what we have some sort of sections, okay, like we see in office rooms. So those sections can be actually arranged in a particular way so that we make their make a unique architecture to serve the overall functionality. So this kind of modularity is called sectional modularity. And at the end we have mixed modularity, where we use a mix of all the three types of modular designs, okay. Now the next question comes when we come up with a functional model, product functional model, which can be a function structure or function tree, how to group these functions into specific modules, okay? So I talked about in the last class that there are mainly two techniques, and one is a basic clustering method where we first create a flow model to create the function structure. For example, if you are making, if you want to try to subdivide or group the functionalities of this particular sensor dispenser, you will first create a flow model. The flow model again is that black box having input, energy, material and signal, and output as energy, material, signal. And after that we try to create the functional sub functions within that, and then try to come up with a function structure. From the function structure we then combine the sub functions into specific modules, okay. Now these sub functions are combined based on if they shared some type of energy, if there is some common sharing of energy or material or signal. Based on that we group those functionals or small sub functions into a group, and we call them as modules. Then we try to create rough geometric layout, okay. Those can be 2D diagrams or 3D form of the particular module, and then we try to understand how these modules interact with each other and try to take appropriate measure in order to avoid any sort of unavoidable situations. For example, if there are some sort of electrical connections, sorry, some sort of internet issue. Okay, sorry for the interruption. There's some sort of internet issue at my side. Okay. uh, okay, so where I was. Okay. Okay, so what we try to see by analyzing the interaction is that in case a particular functional block, okay, when we are trying to group them into particular modules, there may be some sort of energy depletion. For example, there can be some sort of heat energy that can pass from one module to another module. So for that, we need to take special care how to separate these modules from each other. Similarly, there can be material sharing between two modules, and there are some sort of liquid maybe this module is using, and if this liquid if this liquid flow to this particular module, then this will spoil the device. Then in that case, we need to create some sort of barrier. So for all sort of signal, material, and energy, we need to see how these modules interact using these input flows. And in case there are some sort of interferences, then we need to take appropriate measures. The other way of grouping functions is using heuristic method. So heuristic method is very similar to clustering method, but here we use some sort of rules, predefined rules, and we do not have to consider a lot of understanding of the system functionalities. We just can take directly, and we can consider these rules directly. So what we do here, similar to clustering model, we create the flow model: energy, material, signal, okay, and then energy out, material out, and then signal out. And then when we try to create various functions and sub functions, okay, what we look for in this particular flow model is there any sort of dominant flow. For example, if you see some sort of dominant path, okay, flow of energy to flow of energy, then we can consider that entire dominant flow path as one particular module. Similarly, there can be branching flows. For example, from this dominant path, another subpath can go out, and then that leads to a material. So that particular, since it is sharing its common material, it can be considered as another module. Then it can be conversion and transmission. So whenever there is a energy transmission or material transmission or conversion, for example, electrical energy of 220 volt to DC 12 volt, if it is happening within these two blocks, then we can consider that also as one unit. Similarly, if solid material is converted into some powder form, that also can be considered as one particular module. So if there are some sort of overlaps, for example, here the dominant part and this particular conversion transmission part overlaps, we can consider either of them. So it's up to the designer how he wants to break down these flow models into specific functional groups. Okay, I hope this much is clear. So this was what we discussed in the last class. So in today's class, we'll be talking about something called as conceptual design, and which is the next phase and very important phase of your product design process. So what we did so far was, initially we come up with need, customer need, then we come up with specifications, then we identify what are the constraints and what are the functions, okay, we took the functions and then we did a functional decomposition, right? Functional decomposition. Then from functional decomposition we come up with this functional flow model, okay, and then we arrive at these architectures, various architectures, like how to break down, how to group together the functions. So at the end we come up with modules. Now these modules, the nature of these modules are still in the form of like writing, like transmit, okay, 220 to 12.5, and these are not concepts, these are more like, you know, written description of how this module will work. And however, in reality we need to actually convert, okay, after that, to something like a, to a conceptual design, okay, where we need to bring these ideas, or the initial modules, the idea of having, you know, breaking a functions into some sort of, you know, modules or chunks, and we want to realize them in some sort of physical form or some sort of reality. So for that we use the technique of conceptual design. So what is conceptual design basically? Any answer? Okay. So conceptual design is basically an approximate description of the technology, working principle, and the form of the product. So now we are considering product form. So earlier we are only discussing about functionalities, product functionalities. Now we are coming to also form. So now we need to come up with, you know, something tangible, you know, something we need to convert the ideas of functional blocks or modules into some sort of ideas which have some sort of form, okay. So basically, as discussed, like we used to have like functional model. So before functional model we used to define what are the various functions. So from need we used to come to specific specifications, okay. Then from specifications we try to identify what are the constraints and what are the functions, and then we did a functional decomposition and come up with a functional model, okay. And then we come up with various, you know, statistical information. We collect statistical information from customers and population, and we try to understand what sort of uh, you know uh, product architecture is required, and again, what sort of modular design is required. And then we categorize various functions into groups, and that's where we did in the last class. And next is conceptual design, where we'll generate concepts. So before concepts we'll generate a lot of ideas. So using these, the modules, so we now have a rough, some sort of rough idea, like how the product functions can be breakdown. So we know that now these products have so many functions, and those can be grouped into these four modules, okay. But at the end these needs to be realized in some sort of physical form, some sort of tangible idea needs to be come into picture, okay. So for that we do the ideation, okay, conceptual design techniques. So we use those techniques, and then we generate a lot of ideas, and using those, from those ideas, using certain techniques, we select certain concepts which we later try to realize into actual products. So this is actual products. So this particular phase from idea generation to a detailed conceptual concept engineering is what we call as conceptual design. Clear? Okay. Okay, so the process of conceptual design is a part of a empirical design process, okay. So what do you mean by empirical? So what do you mean by empirical design, empirical study? So, so any idea? So empirical means something that is, scientific, that can be, repeated, okay, that can be repeated, and it can be verifiable also, okay, and measurable. So these are some of the, things that makes a conceptual design process empirical, so that, we can follow a systematic approach of design, and whatever decision we make during this particular design, conceptual design process, those can be verifiable, those can be, again, whenever repeated, they give the similar results, those can should be measurable in terms of concepts, you know like the specification wise, where they stands, in terms of, those are like, later we'll discuss about those. So there are some sort of matrices we use to evaluate the concepts, so we can measure various concepts. So in a empirical study, what we do, we generally do this to gather some sort of initial design knowledge base, because many times we do not have actually any, we may not have information about the detailed functionalities requirement or the components requirement for a particular design. Okay, so whenever we, come across some new uh, problem area, and we do not have the idea like how to solve, okay, so we use some sort of design knowledge base uh, to generate ideas, okay, because the nature of the problems are not always like design a refrigerator or design a television, okay. The problems can be very, the nature of the problems can be very, abstract, like, something like, okay, I have a problem of, sleeping. It's like I always sleep whenever I walk, okay. So, at that level, you may think about either, changing your shoes, or actually you want to change the road itself, a lot of things, you can consider. So at that level, we do not know exactly where the solution will, take into picture. So, for, having some sort of idea to initialize with some sort of, useful ideas, we generate some sort of design knowledge base. So for that, what we do, we collect various, products which are, which you think, appropriate for this particular solution, or for your particular problem, and you try to derive, each product's functional models. So for example, this particular example I gave, like, you have a, your father often, sleep when he walks. So maybe, you try to identify some sort of solution for that. So when you search for solutions, okay, so there may be solutions which can be like a change of the sandals, okay, that can be one solutions, or, provide some sort of stick, okay, or, give a umbrella to him, so that, the rain, he do not have to walk in a rainy scenario, so he may slip because of water. So that can be also a solution. Or, he have some sort of postural defect, so, give some sort of postural correction, some sort of gadgets, okay, maybe some sort of uh, bandage or something that gave him, and you give him, and then after using that, he do not fall. So, the ideas can varies, and the problem remain the same, and for the similar same problem, there can be multiple different ideas how you want to tackle that particular concept, a particular problem. So what you do here, we you take each of these particular concepts and then try to products, and you try to identify the functional model of those, and you try to document their components. For example, if you consider it like a sandal, okay, then you try to see what are the components and why this particular sandal does not slip in a wet road. Similarly, why this particular stick does not allow the person to fall. So all those components for each of these particular products you can document, okay. And during this particular process, if you find, okay, that while initially doing product functional model, if you find that certain components were missed during the functional model, then you can again reiterate and make changes to the functional models. Then what you do, you try to understand the functionalities of these particular products, and you want try to see what sort of modules they consist of, and you try to map the various components to those functionalities, okay. And then you record, basically made a record of all sort of this function and component metrics. So whenever there is a function, for example, this umbrella have four functions. Like for example, function one is to protect from rain. That means the component is the top, top cloth. Then function two is to, okay, it has that handle, okay, so you can also use that particular umbrella as a walking stick. So that is provided by, that is like a support. So support walking. So that you can say like it is because of this wooden handle. So similarly, you try to map all sort of components to functions and try to then create some sort of matrices. Based on your matrices, you try to identify useful concepts, okay, and then you create a database for yourself. And this database can be used later for your own problem. So the exact problem that you are trying to solve for your grandfather, which was like he got, he used to get slipped every time when he walks in a wet ground. So you may decide to address that particular problem from a different angle. So you may look for some other solutions, but you can use that particular database to pull some of those useful concepts. So the idea is like you reuse, basically you reuse whatever is best available, reuse whatever best available. So you do not have to invent the wheel again, and just concentrate on those aspects for your conceptual design which are not met yet through existing designs. Okay, so conceptualize for new functions. So for existing functions, like for those functionalities where there is a existing solutions available and which are already efficient, then reuse those concepts. Clear. So that's how empirical design process is done. So basically this is the start of a conceptual design process. So after step 6 we enter into the conceptual design phase, okay. So the concept generation methods can be classified into mainly three types. So there are many concept generation methods. Of course, there are not many people use systematic approach, or s- some sort of this scientific approach for creating concepts, and those we call as conventional methods. Basically, if you go to any workshop, people there also come up with new solutions. They try to create solutions for certain problems, and for that they try to use whatever existing available. They try to do reverse engineering of some of the things that are already available, and they may use they may use like hit and trial techniques. And in most of the cases they have they come up with limited ideas. Basically, if you see some person who is trying to create some sort of bicycle seat for long journey, probably he will modify his seat with some sort of foam or something, or he may come up with new ideas also. But in terms of ideas it will not be much, because he do not use extensive concept generation techniques where a lot of ideas could be generated. Okay, so those techniques we call as conventional method. So in conventional method we do not use any sort of systematic approach. Basically, it's like whatever background knowledge we have and whatever problem we think we face, and whatever solution we feel like it will work, then we start straight away developing those concepts. So that's what is conventional method. The another method is intuitive methods. So there are several intuitive methods available. So these intuitive methods are based on creative thinking process. A designers or a group of people do divergent thinking to come up with a large number of concepts. Okay, so you come up with a lot of different ideas. Okay, and then from use from those ideas you come up with you select certain idea for further conceptual development. So there's a difference between idea and concepts. Okay, so idea versus concept. So an idea is basically something which is abstract, ill-defined. Okay, ill-defined, however it's trying to define a solution which is not it doesn't have much detailed description how it can be done, and there are not much detailed also provided what are the advisory or adverse effect of in what are the difficulties in developing that particular concept. However, a concept is something which is a bit definitive in terms of its working, and we freeze the working principles. We freeze a particular idea into something more concrete, and having detailed information about the working mechanisms, working principles, and the form, etc. So it is more definite and concrete. So initially using the intuitive methods we generate. So basically these are all concept generation methods. So using these techniques, first we create lot of ideas, and from the ideas we come up with some sort of detailed concepts. Okay. So the another method of concept generation is called directed method, which is a logical way, a systematic approach by which a particular solution can be think about. So there are different methods like trees, inversion, etc. So in this particular class, I will be talking about the intuitive methods, which will be more more creative from the way those used to be organized. And the two techniques I'll be discussing today is brainstorming, and the other is 635. Okay. So what is brainstorming? So you might have heard about this particular term in in a lot of occasions. So brainstorming is basically when we do some sort of group discussion, and during the discussion also we think and try to put forward our ideas into the group. So those that particular technique can be also used for product conceptual development. So basically, in a brainstorming session, we used to have some sort of we need to have a group leader, and also we need to include people from varying background. Okay, so this is important because we do not want our ideas or solution to be biased, from some particular field or some particular discipline. Okay, so it's always important that we get ideas from different people of varying discipline, and anyone can be part of a brainstorming session. Generally, brainstorming sessions are conducted for 30 to 40 minutes at one go, and we always encourage wild and exaggerated ideas. Okay, because many times, although those looks not logical at the initial phase, but sometimes those may also work, and that can be an excellent ideal solution at a later phase of conceptual development. So never throw away, like the wild ideas. Always encourage people to give wild and exaggerated ideas. Those also can be helpful sometimes. And then what we do is like ask you need to ask people. Okay, whenever you are conducting some sort of brainstorming session, you always ask others to build ideas on others ideas. Okay, if someone gave the idea, like, okay, we can have, for example, for this particular example, that slippery example. So in someone gave the idea that the sandal should have some sort of rough surface, okay, at the bottom. Someone can build on top of that. Okay, those edges can be like hard. Those can be like you can use some sort of hard plastic for those rough surfaces. So you can build always on others ideas, and slowly you can actually can have a different direction to the whole idea. So you can build on one another's idea, and at the end you can end up having some sort of under idea. You always record all the ideas, and then at the end you do memory mapping. So what is memory mapping is basically, for example, in this particular example, what we say, like, the problem is like that, sleep, right? Sleep is the problem. Now, one solution can be a sandal. Okay, okay. So people can give idea of sandal. Someone can give, okay, and there can be the roads needs should be roughened. Okay, so road, concrete needs to be rough. Okay, and someone can give the idea like, okay, use umbrella. Okay, someone can say like, okay, uh, you know correct posture. Now see, these are ideas. Okay, so these are not actually in the form of some sort of concepts, but those are like very abstract ideas, like correct posture. Now next, someone can give ideas, okay, how to correct posture. Okay, so we are now trying to build on someone else idea. Okay, so someone can give another concept. So correct posture. So correct posture can be using some sort of leg guard. Okay, someone can give like use exoskeleton. Okay, similarly, someone say like, do not use umbrella, you used similar like a hat. Okay, so this way of mapping the ideas and their flow from one idea to the another idea, and trying to group them into, try to affinitize or group the ideas into some sort of categories, is what we call as memory mapping. So this is very important, so that later we can easily see the different people's thought process, and in which particular areas all these uh, ideas fall. Okay, and during the idea generation process, sometimes there can be silence, because people may not have any sort of clue, or and they may face difficulty in generating new ideas. So then there can be some sort of trigger questions or trigger conversations, okay, to initiate the ideation process again. Okay, so that is basically the brainstorming process. The another intuitive technique, which is the 635. So 635 is basically six people, and each of them will generate three ideas, and there will be five rounds. Okay, so how this will be conducted? No, this it's written here. So basically, you used to have some sort of round table, and where there are six person, okay, and you give a sheet of paper to all the six participants. Okay, so this is the first thing you do. Second thing is like you ask them to. Second step is to ask them to write three ideas. Second, you allot some sort of some fixed time for that. For example, if you give 5 minutes to all the participants, that okay, write down three ideas for this particular problem, this sleep problem. Okay, so each of them will write their individual ideas without discussing with each other, and next you will ask them to pass this particular paper to the next person. Okay, so either you can consider a clockwise rotation of the sheet, or or anti-clockwise. So when the person receive the other person's paper, then he is again asked to suggest new or additional ideas on top of those ideas. Okay, so there can be ideas which are built on top of previous ideas, or the person can also, those previous ideas can trigger some new ideas, and that person can actually uh, come up with some sort of new idea. So then again, in that particular step also, you give them some sort of fixed time. For example, 10 minutes you give them, and ask them to write new ideas, and then pass the paper to the next person again. So this way, like for example, in every step you consider 5 minutes. So 5 minutes, three ideas. Again, this paper moves 5 minutes. So after 1 2 3 4 5 person, you end up with 25 minutes. And whenever this particular paper return to the first person again, okay, so everyone will get their own original papers. That means one round is complete in this particular process. So you need to keep on doing that for another five rounds. Okay, so in between each round you need to give them a break for discussions. Okay, so these discussions will help them in generating and clarifying additional ideas. Okay, so this is the methodology of 635. So very similar to brainstorming. However, the problem with brainstorming is like you have so many people, and what happens, like generating a mind map at the end of a brainstorming session is again difficult. However, in this particular process, when you actually pass on your papers, people try to write down the ideas and on top of others. So you start developing the records of the ideas concurrently. So that is the benefit. Okay, clear? Okay. Okay, so one of the very important aspect in conceptual design is like you need to have all sort of information, okay, for idea generations. Okay, someone who do not have any specific knowledge about this particular problem area, and who is not, does not have a basic knowledge of, for example, any basic scientific knowledge, engineering knowledge, for them actually giving some sort of useful ideas will be difficult. So it is very important that before doing some sort of conceptual design, you do a dynamic search for data, so that everyone, whoever is in the particular team, like organizers, they need to have some sort of basic knowledge so that when you start the conceptual like brainstorming session, you give the participants some sort of initial briefing, so that okay, they will also have some sort of idea like what sort of technology they can use, what sort of mechanism they can use. Okay, so that is that will be that actually helps a lot. Okay. So there are various sources of information that one can consider for collecting this information. So one way can be benchmarking. So whenever if there are some sort of existing product that you want to modify, you want to create a new product based on some sort of existing product, then you can do some sort of benchmarking. So whatever different products available in the market of similar requirement, so you can study their functional components. You can dissect them, you can see their functional models, you can see how in terms of modules they are organized, and what are various functional components they use and how they functions. So all those informations you can collect and using benchmarking. And again, if it's a new area where you do not have a domain expertise, in that case also benchmarking will help. Sometimes you do not have uh, a concrete information, but you have some sort of basic knowledge about scientific principles, but and based on that, whenever you dissect some unknown device also, you may understand like the working principles. So benchmarking, dissecting competitive products will also always help in acquiring those sort of dynamic informations. The other ways can be like analogies, like whenever uh, you try to generate ideas or concepts, during the ideation phase, the analogies from nature, other products functionalities, other products architecture sometimes may help. For example, you may think about creating some sort of uh, fan or bicycle, hubless bicycle, where you do not want to have some sort of spoke. Okay, so you may think about something analogical. For example, you can consider Dyson fan, which does not have any sort of blades in between. Okay, so similar thing you can consider. So those can be like ideas, initial set of ideas, like how a hubless bicycle wheel can be. Okay, so those analysis sometimes works. So you need to have information on analogies. Then you also can consider published media information like patents, journals, product informations, textbooks, reports, etc. You can always consider people's knowledge, like those can be feedback from customers, and there can be experts opinion, there can be professional who are working in the field. Sometimes you do not want to, since you are not from the particular domain, you try to invent something, but person who is professional, who is working in this particular field, he may have a better idea like how that particular thing can be achieved, or he may have a ready-made solution which he may know but you may not know. So that way, discussing or talking to people help you getting appropriate information in concept generation. The other kind of source is web, where you have YouTube and various internet based sites where a lot of information can be collected for before you start generating your concepts. Okay. Okay, so here's an example of a conceptual design process. So this was a project done by me for a wound therapy device. So in terms of information, so dynamic information, what I collected was all sort of existing solutions that are currently available. So for me, this particular domain, so I'm a product designer, but no, I do not have a previous exposure in medical devices. So I do not have much knowledge about how what are the various technologies and how chronic wounds can be healed. So what I did was like I studied various wound healing technologies, and I tried to get some sort of data from internet and try to later see various web-based information to understand how these particular technologies works and how much market capture they take. Okay, and also we try to understand what sort of limitations these technologies have. Okay, so based on this initial information, we conducted some sort of brainstorming session, and where we invited participants from different disciplines. So there were doctors, there were engineers, researchers, and a group of researchers who actually took part in a brainstorming session, and they initially gave ideas. Okay, so here is how those ideas are later converted into some sort of visual and pictorial representations. So initial ideas were very much in a rough format, okay, like a notebook, but later those were converted into some sort of good visualizations, so that those are easy to understand. And this is how the memory mapping is done. So for example, the ideas related to antimicrobial dressings are grouped like this. So these are various antimicrobial concepts or the ideas that we came across. Then ideas based on electrotherapy are again grouped. Okay, so sometimes those are incremental ideas, like based on others ideas we try to develop. Okay, so this particular branching can be like from this particular idea also you can have branching. Similarly, these are mechanical suctions, where the idea was to suck the exudates, wound exudates mechanically. Okay, so these are various concepts that actually the participants gave. Similarly, there are ultrasound based ideas that people gave. Cold plasma was another technology which is also useful for wound healing. So a lot of people gave ideas regarding cold plasma. Negative pressure wound therapy is again a popular technique, so we can have some sort of concepts on negative pressure wound therapy. So these are the actual some sort of ideas where later all those ideas were converted into some sort of concepts, and then we select some one of the concepts for further development. So this is how the final concepts looks like. Okay, this is the idea. Okay, so in the idea generation phase, this is more like a rough. Okay, this is just a rough work. Okay, we don't have much idea like what is going to be inside this. We just have some sort of basic knowledge, like okay, there will be some sort of the device will have some sort of own exudate collector, etc. It will be connected with its addressing, and later when we realized what needs to be go inside, then actually we come up with some sort of concept, like what should be in the display, what how many buttons should be there, and what sort of buttons we need. Okay, and how big should be the exudate chamber. So all those you know detailed information we can capture at the concept generation stage. This is the concept and these are the ideas. Okay, so I hope this is clear. Okay, so that's it for today's session. So thank you for joining this particular session. So if you have any doubt, please feel free to ask. Okay, thank you. So next class is again in the next Tuesday. So, okay, so if you have any doubt, please feel free to contact me. Okay, and please finish your week 10 assignments, those who have not finished it on time. Okay, thank you.